Hi, so in this class of IoT today, we will study the architecture of your IoT systems, of your Internet of Things. So basically, the architecture of your IoT will comprise of the different technologies, different technology suites that makes work it as a complete one system here. So there are different layers, as we know that in your IoT, it starts from your uh, sensor level to your cloud platform. So there will be a number of intermediaries in between which will be making it as a whole IoT system. So we will start here from the very first layer, which is your sensor network layer. This is typically your sensor connectivity layer. That means it will comprise here the different number of sensors which will be collecting the information from the physical world. So that basically can include here your GPS, your electrochemical, photoelectric, these kind of sensors here. And it will have your RFIDs also, like your radio frequency identification and your barcodes. Now, this will be the first layer here. So, after that, these sensors here need to connect to some aggregators, which will be aggregating the information from that. So, that means there will be a gateway layer. So, that means these devices here, some of these devices which needs to connect it using local area network, LAN, or some with the help of your personal area network. Now, different technologies will be used under these access technologies here. Like it can use the Wi-Fi and the Ethernet here, and it will use technology like your Zigbee, no Bluetooth energy, and like a near field communication. So, from the sensor hub, you need to connect to your gateways. That is to your gateways and networks. You need here to connect to the gateway network. Now, your gateway network will have LAN and your wide area networks also. So basically, it has your Wi-Fi or your Ethernet, and this can have here your GSM, UMTS, narrowband, LTE, and upcoming fifth generation of cellular technology. Now, from gateway networks, these are basically needed here to connect to the internet or your cloud platform. So after that, you will move towards your cloud and internet here. So we had here sensor connectivity layer, your gateway layer, then your cloud and internet. So basically, this falls here under your management service layer. Uh, I'm just going to remove this one here. So this is basically your management service layer. So this will be performing the different analytics here, the processing of the informations. But beside that, it has certain departments like your OSS, your BSS, which is basically your for like device management, device configuration, your operations, and like your billing and reporting of the system. So this is the third layer here. After your sensor layer, your gateway network, you have your management service layer. So above management service layer, we have, you can just write here your cloud and internet services. But the fourth one, which we have here, is your consumer layer. That is, we can classify it as your application layer here, which includes a numerous application. That means the users platform ranging from your like retail, healthcare, and transport systems, etc. So we have here the sensor connectivity layer, the gateway networks, the management service layer, and then the topmost, the application layer. So we will study here each of these layers one by one and what are the various technologies which are enabling this platform, this architecture for your Internet of Things here. So first of all, we will begin with the very basic and the first layer of your IoT architecture, that is your sensor layer. The first one which we have here is your sensor connectivity layer. Now, this is your sensor house. That means a number of nodes here. So the sensor connectivity layer, we can say that consists of a large number of devices, your smart devices, which are here integrated with sensing capabilities. That means integrated here with your sensors. So we have smart devices integrated with the sensors, which are here able to capture the information from the physical world. So that means these are capturing here the physical world information and then transmitting it here to the digital world, to your digital world. So we can say that these sensor devices are here acting as an intermediary between our physical world and the rest of the digital world, or we can say that the rest of the IoT system here. So these are here able to capture that information and then transmit it to the further layers so that the data can be analyzed, or we can say that the data can be processed here. Now we have a number of sensors here. That means they're able to capture a number of measurements ranging from your like They can monitor your activities like walking, your talking, and other activities. We can say that they can sense electricity, temperature, air quality. So different sensors taking different kind of measurements here from the physical world and then transferring it to the other layer. That means the analytics layer of your IoT architecture. So we can say that the compactness of these devices has led to reduce the size of the embedded devices which we are going to use. So that means high capability sensors are now embedded into these kind of smart devices here. So these sensors are here categorized as your like industrial and automation sensors, the body sensors or your automation sensors, etc. So with these sensors, we're using the RFIDs also, the radio frequency identification tag. So these RFIDs are basically used here for like asset tracking. So these are the systems or these are the technologies which are here in your sensor layer. So basically, when we need some intermediary which can transfer the information, so we have your smart devices embedded with the sensors and measuring different kind of information here from the real world here. Now, this is here about just your sensor connectivity layer. We will be studying about the different kind of sensors in our another session. So most of these sensor devices need or they have a desire or it's an application of these sensor devices that they should be connected to some aggregators. So these aggregators are here basically referred as the gateways. Now some of these sensors are here connected to your personal area network. So that means we need some transition medium, a transportation medium. So some of them are using technologies like your Zigbee. Some of them are using low Bluetooth energy or IPv6 over low power. That means we're using that for your personal area network. So these are the technologies which are enabling your IoT. So we will be covering these technologies in our another sessions. So some of these sensors can directly be connected to your backbone network. So that will be connected like to your UMTS systems or your 4G systems here. So that means after the sensor connectivity layer, it means once the information is collected, that needs to be transferred here. So you have the sensor hub here that needs to be transferred to the gateways so that gateways can forward it to the internet or your cloud platform. So here different technologies are enabled. That means they're using here IP. Some of them, because these are not directly connected here to this layer. Some of them are connected, so they're using your 4G systems or your cellular systems here. But the ones which are not using here, they're using your wireless sensor networks so that they can reach this system through your gateway. So that means gateways here are used to connect two different nodes here. So after the sensor connectivity layer, we have the gateway network for your IoT architecture. Now we know that tons of data will be generated through these tiny sensors. Now the data which ever is generated here, that needs to be transferred to this layer here. So we need a strong transmission system here through which it can be transferred here. And that's the most dominating technological challenge here for IoT. So that's why we have the gateways here. So that means the gateways are here are used to mitigate or to transfer the information from this end to this end. And some of the gateways are also responsible for sending the information to the nodes also. That means two-way transmission here. So there are basically two different type of gateway implementation here for your IoT. The first one is your simple gateway, and the second one here is your embedded control gateway. Now, for your simple gateways here, the simple gateway will simply organize the data and convert into packets. That means forming a particular frame here. So it organizes and packetizes the data so that it can be transferred here to your internet or to your cloud platform here for the analytics of that data. So that means this system here doesn't control any other thing except the transmission, just only forwarding of the data which is being here generated by the sensors and the actuators here. So now there is a need to differentiate between here the router and the gateway. Now, router is basically used to forward a similar kind of traffic, and routers are basically used to connect the devices that have a similar interface. But gateway here acts as an bridge. That means it must accommodate all types of traffics. That means gateway here is able to send the information which is aggregated here from the diverse devices, because these are your sensor integrated devices. The devices all are not similar, but they are here from different vendors and different devices. So gateway here is responsible for aggregating that information from the sensor hub and forwarding on that bridge. So that means it's acting here like in bridge, which is transferring that information to another higher layer. So this is how your simple gateway works. It simply organizes your data, packetizes and then forward it to your analytics layer. Now above that we have embedded control gateways also. Next is your embedded control gateways. So your embedded control gateways basically extends the functionality of your simple gateway by adding the resource processing, or we can simply say that by adding some intelligence to this gateway. That is the adding resource processing and intelligent handling of the different nodes here. So in this embedded control gateways, we can say that the gateway here is able to filter the various kinds of data. So this basically reduces the cost and the complexity of the node. So that means every time we just don't need to change to we don't need here to change the interface of the various devices if we have to collect the data from that. So that means it here provides the interoperability. So it minimizes the changing of the interface here by adding these two intelligent protocols in your embedded control gateways. So gateways are here acting as a now intermediary between your internet and the sensor hub. Either there is an implementation of your simple gateway or your embedded control gateways. Now, like Cisco's IoT gateway that implements IPv6 protocol stack, so that also provides interoperability. That means, despite of any kind of device from any kind of vendor, it's able to blend in that environment. Further, the Intel's IoT gateway also provide connectivity to the sensor hub and the connectivity to your cloud platform also. Now, these are the two types of gateways here for IoT. After that, we have that how these IoTs can be implemented. These gateways can be implemented within your IoT. So we have basically three different type of category for that. IoT gateways, implementation here. So the first one which we have is your via IoT gateway. That means whatever the information is processed, that is via IoT gateway. Now, first of all, we will have your if you have your internet here, the internet router here. Now here you will have IoT gateway and the IoT agent. So here you will have your number of nodes. Like you can have here the Zigbee node, your Bluetooth low energy node, or IPv6 over low power, or your wireless personal area network nodes. So this is the scenario here that we have different kind of nodes here. So when we can see that these nodes are here not directly connected to your internet. So rather they're using your IoT gateways here. This. Now here it has implemented an IoT agent. Now this IoT agent communicates with these nodes here. Zigbee node, BLE node, or your IPv6 or low power node. So these will communicate with this agent, and this is then forwarding that information to the internet. So with the help of these gateways, the information is transferred from this end to this end here. So this is the gateway implementation. That means how the information is processed using these IoT gateways. Now another scenario deployment of the gateways is the direct. Here you have this intermediary. Above that you have directly connected to IoT nodes here. So you have your internet here, your internet router here. Now here we have the direct communication. You have here IoT agents. Simply the IoT agents. Now these IoT agents are here. Now this could be either your Wi-Fi mode here, or it could be your Ethernet mode here. Now here you have different number of your sensors and actuators. So these nodes here are directly connected to the internet here. So when we have such kind of system here, so they are connected here with the IP, because you're using here Wi-Fi and the Ethernet. So this connectivity here is enabled with the help of your IP module. That means here no gateway is deployed. Simply these agents are performing this to and fro transfer of information. Third mode is deployment of another kind of gateway, which is your directly linked IoT nodes. So this is similar to the previous one, but instead of this is your internet and your internet router here. Now, despite of that, it is using here this technique, IPv6 over low power personal area networks. So this is your gateway, IPv6 gateway. Now here you will have the IoT agents, but you will also have this personal area network nodes and your sensor. So that means this is the gateway, this is the IoT agent, and this is your node supporting these systems. So this is gathering information here, transferring to this gateway, and then this gateway is routing your information to the internet. So that means we have two techniques here which is employing the gateways here. One is a completely different way, which is using your IPv6 over low power for your personal area networks, and the first one which we studied that has your that can have your simple gateways, or that could have your embedded control gateways. And in between we also studied where we have the directly nodes connected to your internet. So that means we're using their your Wi-Fi systems or your Ethernet, which is connecting to the internet here. So here we have just studied about the two layers of your IoT architecture, that is your sensor connectivity layers, which consist of various types of devices which are integrated with your sensors, which are acting as an intermediary between the physical world and the digital world, taking the measurements from the physical world and transferring it to the digital world here. Now, how that information is transferred over the other layers? We're using this gateway layer for that. Now we have above that the cloud platform and the management services layer. So we will be continuing with the rest of the layers of your IoT architecture in the next session. Thank you so much.